Hi all, how are you doing? Um, Afternoon, afternoon, students. Can you?
Good afternoon, sir.
Yes, yours. How you doing? Is good?
Sir, I'm doing good. Sir, how are you?
Still under the weather. Still under the weather. I'm just trying to figure out something here at the pharmacy. I sent you something in the chat. Can you um action it for me, please? Please, thanks.
Okay, sir.
Can you bring up one of the years so we see, and let us look at one of the calculus questions.
Sir, you see my screen?
Yes, one, I'm seeing it, but I'm not seeing. I'm only seeing the I'm only seeing the list of files. So I'm asking you to go ahead and just open one of the past papers for me.
Okay.
Any year is fine by me, but I want you to let us see if we can try some of the calculus ones. Um, or you know what we could do? Let us see if we could find something on the regression correlation. You're searching from the keyboard here. Still not seeing the question showing up here, hon. Can you click on it, double click on it, and bring up one of the past papers, please?
So I think the internet is moving slow because I'm on it, but it's just not showing.
Oh, you have a problem. All right. Try as best as you can. I'll do home shortly.
Oh yeah.
All right. I think any other questions on correlation and regression?
Please? No, oh, okay.
I saw one, but it was just one, just a question asking you to plot a scatter diagram. I was looking for
Oh,
one that is longer.
right. Please, sometimes.
So I found one.
All right, great. Now, I'm going to ask that the class start working on it for me, please. It's on regression.
Yes, sir.
Okay, start working on it for me, please. Then you can scroll up according as soon as you ask you to do that. Thanks.
Daniel, go back for 1 second, please. We did just come. Can you scroll down?
So what is part CI? The question that you just showed a while ago?
It's Tanya that is sharing the you can just ask All right, guys. I'm just looking at the first part of the oh Lord, sorry. Is this the start of the question, Tanita? It says a group of people from a neighborhood is investigating. That's the start of the correlation question.
Yes, sir.
Okay, all right. So I'm looking at it and I'm seeing the number of marks, 3 marks. I am thinking really and truly, if I were given a question like this, it would be a 1 mark. But maybe I'm misreading the question. So um, let me just see how best I can go through the question. It says a group of people from and I'm being very deliberate in what it is that I'm doing here now in terms of, I mean, I have just 1 or 2 areas to finish off, but it don't make sense to finish off, and then we're not practicing some of the questions as we go along to see how they pitch it. Because clearly, how I pitch the questions with what I'm teaching you is much more than what the exam is pitching for you now. Because they gave you why, they gave you the regression, the least squared regression line. In my class, you had to find the least squared regression line. I'm not giving it to you, right? So you'd have done a little bit more than what this question is requiring of you. But anyhow, I'm happy it happens that way and not the other way around. It says a group of people from a neighborhood is investigating the relationship between weight loss in kilograms and the number of weeks of exercise. Okay, so one of the things is once it is that we're comparing 2 variables, more than likely is correlation coefficient. All right, 2 variables. So comparison of between 2 things. It says the linear regression, bam, we're on track. The linear regression equation is 0.186 plus 0.64 x was obtained. Y is treated as a dependent variable and x as an independent variable for the number of weeks of exercise. Okay, so we know what is happening. So x is representing the number of weeks of exercise. So x is exercise and y is weight loss. Using a given regression equation, determine the weight loss during the 24th week if no changes were made to the exercise. How did you do this one?
Sir, I substitute 24 into X.
Oh, absolutely. That's all you need to do. All right, I can't find my calculator, so I'm going to ask. I'm depending on you guys to help me out with this one. I don't know. I have a terrible headache, so I really don't want to hold my head down to look for it. All right, so it's going to be very good though. So when you multiply 24 by 0.64, what do you get?
15.36.
15.36.
15.366 what? 15.36 what?
Yeah, that's one.
Huh?
15.36.
Oh, that's alone. Okay. All right. So let me just use it as a point, a teachable moment now. So it's because the first term was to 3 decimal places that you're going to be adding 2. You see, if when you multiply the 0.64 by the 24 and got more than 2 decimal places, I would have used 3. Why, sir? Because when you look at the 0.186, they give you 3 decimal places there to add. So I would have gone to 3. But because you have only 2 here, it's perfectly fine. So it simply means that everybody should get the same answer. And the answer is what? 15 point what?
546.
546.
15.5. All right. Using the given regression, determine the weight loss during the 24th week if no changes were made to the exercise. Weight loss. What's the final answer?
There was 16 weight loss during the 24th week.
No, man. I'm asking, what's the final answer? What's the final answer for part 1?
15.546.
15.546.
No. Remember, that's a mark for CXC here. So when I said no a while ago, you guys will get only 2 out of the 3 marks.
15.546. Yeah. kg.
Thank you, please. So let me. The kilograms is missing, so you'd have lost a mark for the unit.
Oh.
So let me tell you how the 3 marks are justified now. 1 mark for the correct substitution, So once they see that you substitute the 24, you get a mark for that. 1 mark for arriving at the correct answer, and 1 mark for including the unit. So if you only wrote 15.546, you'd have gotten only 2 out of the 3 marks. All right, so we have to be very careful, please. All right, all agreed?
Yes, sir.
C1, C2. C2 says the correlation coefficient R. The correlation coefficient R was found to be 0.981. Comment on the accuracy of the answer obtained in part E1.
Sir, I put that there's a very strong positive correlation between weight loss in kilograms and the number of weeks of exercise.
So I say that there's a moderate positive correlation.
Why is that? Why is it a moderate positive correlation?
So because it's below 1.
Okay, all right. I'll come back to that. Come back to you. Come back to that. Let me hear what the rest of you say. What? How many marks for this one? This is a 1 marker or 2 marker?
2.
2 marker. Okay, kind of figured. Anybody else?
There is a strong positive correlation because just the one.
Anybody else? Thank you, hon. Anybody else? Anybody else? Talk to me now, man. We did this for the last 3 weeks. We've been looking at this, man. Talk to me. You remember I did say to you, and this is why I said to you, it's very important that I don't just do the SBA, but to get you into the whole hang of it. Oh, and incidentally, let me just apologize right at the bat. I was supposed to be meeting with different group members, but when the mind is and the heart is very willing, but the body is very weak and can't do not more than that. Yeah, that's what happened to me. So I know the honest truth though is that this is the absolute cutoff week. They have to get to CAC by Friday of this week. So God is good, continues to be good. Trust me, I have to respect him every day. So he has given me a little bit more time. So I just went to the pharmacy a while ago and bought some more tabs. So I just took a very drowsy one to see if I can just sleep off this terrible headache. So hopefully it will set in by the time your class ends. So if you hear me talking foolishness, so that it's not of my own will. Right? It's because of the medication. All right. So I say this to say to you that this is why I wanted you guys to work on the thing, because based on my reading the stuff, it says the correlation coefficient R was found to be 0.981. Now, I've seen a past paper where they gave you the stuff for you to calculate R. This one, them just want a 5 marker, and as a result of that, them just give you 3 marks up top and then a 2 marker down here. So, matter of fact, let me ask somebody else. I heard from 3 students. Let me hear from somebody else. What comment? How do you comment on the accuracy of the 15.546 kilograms? I just need one other person before I come in. None of you should be in a position of being muzzled. You should all know what to do here. Let me call upon somebody then. Since nobody wants to volunteer, let me call up on Mr. LaForest. Matthew, comment on the accuracy for the answer obtained in part A for me, please. Matthew?
The strong positive correlation between the weight and exercise. Can you hear me, sir?
No, me I hear, but Lord, you just drive it so. Anyhow, thank you. You just drive it so. All right, so yes. So there is a very, not just strong, there is a very, very strong, not moderate Kasana, a moderate correlation would be something like 0.51, a 0.498, or a 0.499. Anything in the 5, anything high 4, low 5 will be a moderate. But if the coefficient correlation is 0.981, and look back at what we did for the SBA, it's a very strong positive correlation.
So what kind of bird you have in your background, sir?
Guess what? My yard is blessed to the point where I feed and have different feeding port for them. So I have blackbird, grown dove, every type of bird. The little nice little one them come and feed. And at this point in time, I can count 1, 2, 3, 4 different nests inside of in the yard. I have 1 on the front and I have 3 on the back. So I am all bird out.
Sir.
So you're on a sanctuary.
Bless the Lord. Go ahead, Chrisana.
So you know what kind of correlation it is? You can repeat what you were saying, please.
All right, honey. All right. So what I'm saying to you is, remember I said to you that the correlation runs from -1 to +1. All right. So I can have a correlation that is -0.981, and then I could say that is a very strong negative correlation, suggesting that it is I'm almost 100% right. Remember, the coefficient of determination. When I square my stuff, then I'm going to get it as a percentage, and that percentage will tell me, how strong it is. Hold on, please. Yeah, so I can have a strong negative correlation. Now, if I have a strong negative correlation, I can say the data is suggesting that there is no relationship. I'm positive that there is no relationship between the variables. But in this case, I can say that there is a very, not a strong, but a very strong positive correlation between weight loss and the number of weeks of exercise. And the number of weeks of exercise. Right? So it's a 2 marker. So you can't just give them any flimsy something. You want to give them and so many lines them give you? 1, 2, 3, 4, 5, 6 lines. Yeah, 6 lines. So what I would write is that R being 0.981 suggests that you have a very strong positive correlation between weight loss and the number of weeks of exercise.
Sir, can you repeat, please?
A very strong positive correlation between weight loss and the number of weeks of exercise. Can you scroll up? Let me see part one again, the introduction to the question, please. Sorry. All right. Between weight loss. Right. And the number of weeks. So if you look at the question, it says a group of people from a neighborhood is investigating the relationship between weight loss, that's one variable, and the number of weeks of exercise, the other variable. The question says to us that X is the independent variable, and the independent variable is the number of weeks of exercise. Right? So the bivariate data is actually saying that yes, the number of weeks of exercise that these people from the neighborhood engage in will result in weight loss. That's what the question is saying. But as I said to you before, based on what we did, we would have done much more than what this question is asking. They gave you the least squared regression line or equation. I didn't give it, I never do that. I show you how to calculate it and went all the way into this stuff. So a question like this here, you should be able to go ahead and calculate it. All right. Tan, can you, by the way, is there any question relating to what it is that we just said? Is there any clarification? Everybody understanding what I'm saying?
So,
Yes, sir.
less than, if R less than 0.5, that means it would be a weak correlation.
Yes, sir. Yes, sir. Yes, sir. I'm not sure though. I don't know if the curriculum has changed because I really never studied it beyond CXC. For CXC English or CSEC English, as you would call it, do you get things like statistical reports to write? Teacher teaching or to do statistical report? No? We never did it when in our
Sir,
school?
don't remember, sir, a long time ago.
Okay. Well, me remember, and a long time me leave fifth form, but me remember doing statistical report and we had to use these adjectives. I see because we didn't love math. Oh goodness, there's no way me cannot get full marks on my statistical report because there are some terms that we have to use to describe it. A strong, positive, a weak, a moderate. You find some different adjectives to speak about it. But yes, if it's like a 0.3, I could say, Matthew, if I'd gotten R to be 1 point something, a very, very weak to negligible relationship. You see, I'm finding another word to put in there. If it's like 0.3, 0.2, 0.3, it's a weak relationship. Oh, there's something else I need to do with the question. If it's, as I say, 4.4 enough, like a 0.499, almost 5, I could say it's a weak to moderate, right? So when I say weak to moderate, no, I'm giving them a range to say, boy, it is a strong weak, so to speak, if you understand that terminology. It is a strong weak, but it is not a very strong moderate. All right? And then now, 0.6, 0.7, it's, I wouldn't even say moderate, I would say strong, right? Or I could say it's a moderate to strong correlation. But once it is 0.8, 0.9, 0.8, I would say are strong. But once you reach 0.9, no, strong, very strong relationship. All right? So that's how we do this stuff. Let's go back to the question. it says to comment on the accuracy of the answer obtained in part C1 above. So it's a very strong relationship. Yeah. So all right. Yeah, I think that covers it. All right. Thanks, Daniel. Can you find another one for me, please, Daniel? Please and thanks. Oh, what year was that? Sorry, sweetie. What year was that on?
2017.
All right. Thank you. I'm just making a note of it myself because we just need to start working these questions. What is that? Let me see that one. I see some numbers. Oh, no. Oh, so it'll come every year then. Oh, so a probability distribution question here. Have we done this? Have we done that?
I mean, sir,
Yes, sir.
would you the question or the topic?
The topic.
Yes, sir.
Mm-hmm. Scroll down to the question, please. Tan. Let me see part 1 and part 2. Hold on there. Oh, no, go back. Oh, I don't understand. What? Go back up on the bunches, please. That's a part 2 to the question. Oh, okay. All right. No, I just got started a while ago. Sorry, and I'm here shouting and my head hurts. All right. Yeah. Let us look at the probability distribution right there. What? Are them things that go on with that question here? All right. Yeah. So this, what year paper is this?
2017.
2017 again?
Yes, sir.
All right then. Cool. So scroll down to or scroll up or down, whichever one it is, to the probability distribution, please. All right, and then I give you a couple of minutes to work that question, and then we're going to go to the pie chart, and then we're going to go to the box and whisker. All right, yeah, right there. Thank you. Sorry. Were you guys calling me? Hello.
No, sir.
Okay. All right. What's the value of Q?
0.3.
0.3.
0.3 will be correct. I just for my calculator, so I'm doing these. I'm doing that. All right. Somebody want to read out the second line for me?
Second line of what, sir?
XPX.
0.4, 1.6, 1.8, 2.4.
Check that one again, please.
0.8.
0.8.
Supposed to be 0.8. Here, Kisana. All right. Somebody else do the other one for me, please.
0.4, 1.6, 6.4.
Excuse me.
0.8, 6.4, 10.8, 6.4.
Oh, sir, my daddy, calm down, sorry.
Oh, okay. Woo. You frightened me a while ago. And then the last one was so 0.8, 6.4, 10.8, and 6.4.
Yes, sir.
Yes, sir.
Nice job. All right, and so you are required to do 1, 2, 3, 4, 5, 6. How many marks I give you for? Oh, just 2 marks. 2 marks to find Q. Oh, cockroach. 5 marks. 1, 2, 3, 4, 5, 6. Wasn't that an easy 7 marks?
Yes, sir.
Yeah, man.
Yes, sir.
Calculate the mean for me now. How you calculate the mean?
Sir, how you get the 0.8?
0. Remember, it's x times p of x, you know, and x is 8, and p of x is 0.1. So 8 times 0.1 is 0.8.
Repeat, sir.
Kasana,
Yes, sir.
somehow I feel like you're distracted.
No,
And
not.
I'm going to tell you why I said that. And I don't have a problem with you asking me the question, you know, so I don't think I'm getting annoyed. It's if you gave me 0.4, 1.6, and 1.8, which were very correct. So if you gave me those very correct answers, you must be able to do the last one. So look back at it, honey. That's the point I'm making.
Sir, when I look back, I'm still
How did you get the 0.4?
2 times 0.2,
Okay. How do you get the 1.6?
4 times 0.4,
How did you get the 1.8?
6 times 0.3,
How you didn't work the last one?
8 times 0.3.
No, ma'am. Look back at the table that Tanis has.
Jesus.
Okay. All right. Thank you.
So you know what was the problem? I think say at the 0.4 was incorrect.
No. You have to look careful at what is given. All right. So you're okay now then, right?
Yes, sir.
All right. So it says calculate the mean and the variance of x. Now, what do we need to do?
Sir, we already calculated the mean when you did the table. So all you need to do is just add everything in that row.
Okay. So tell me what? Oh, sorry. Yeah, never mind. Already got it, so I don't need to say it. All right, so calculate. I'm supposed to calculate what not to use?
The variance of x.
On what you got for the variance of x?
3.24.
Everybody agrees. Everybody agrees with 10 years. Hmm.
Sir,
I'm asking if you agree with 10 years.
what was the answer, sir?
What was the answer again? 10 years.
3.24.
3.24.
Yes, sir, that's what I got.
Anybody agrees with 10 years? I disagree, you know.
Right, me get.
You get that's what you get. Matthew is saying that's the same thing as he got. All right. Let me just check the chat. All right. So answer Shanshan. How about buckler talk about? Not to be. If you ever make me find where you live behind Jesus, you see, and put you across my lap and beat you. You not understanding what is happening?
Sir, no, I never did I understand, sir. Remember, I never there Friday and the other Friday, you know?
Mm-hmm.
Sir,
No, sir,
Yes,
the Friday before that, I did a funeral. And then the Friday here, sir. So one news that girl, I'm a catch it. You see that cough the way I have?
talk truth.
It me did have, sir, but me did have fever and them things, so. Me did
Wait.
all hallucinate at one point, sir. So,
Talk truth.
gone.
Talk truth, yeah, man. Something is going around. I mean, of course, it's not COVID, but it you know, it's wicked, man.
sir,
Yes, honey.
we get negative 202.3.
You need to change the batteries for that calculator.
If what, sir?
Change the battery for the calculator or change the calculator.
You're serious? What? Battery?
As a judge. No, I'm not very happy tonight. I'm not very happy tonight because I asked a question. I am saying that I disagree with Tanya. Let me just double check my answer again. I'm disagreeing with Tanya, and nobody else. Matthew was the only one who came and said, "Sir, I have the same thing she get me get." And I'm saying that I'm disagreeing. Oh, Rockstone. Hold on. Hold on, because I wrote something down. I wrote 24.6. It's supposed to be 24.4. And see, the 24.4 up the calculator top, you know. See, the medication started settle in. It's supposed to be 24.4 and not 24.6 minus 4.6 squared equals 3.24 is the answer. No, wait till you get for the answer. I'm telling you, 3.24.
Yes, sir.
Oh, I was getting 3.44, and the reason I was getting 3.44 is that when I did my calculation, I got 24.6. It's supposed to be 24.4. So you are correct, honey. I made a mistake. All right. Okay. Yes, Matthew. Congrats. So. All right, let me just explain what is happening now. So how sir taught you this stuff? Different teachers teach these statistics differently. All right? But if you follow the sequence, you will always end up at the same answer, the same result. Now, you notice how I did this stuff when I was teaching you? I don't carry it to the side. I normally put it up top. So it's a different orientation, but it's not a problem. And then now they put xpx and x squared px. The xpx is representing what? What the word you want to use?
Mean or E of X.
E of x, right? The expectation right there. So very good. And what it is that they are asking us to calculate now in terms of var x. Var x is going to be the E of x squared minus E of x all squared. So even if you didn't know that, just look at the x squared one and know, so the x squared, when you already give it something, start to put the x squared one at the front. And then the E of x, all squares come at the back. So therefore, we're going to have the 24.4, not 6, 24.4 minus the 4.6 all squared. And that will give us our 3.24. And that's a variance. And that's a variance of x.
Sir, when I get it.
Can somebody explain that for me, please? Nobody wants to explain it, please?
Sir, but my background is noisy.
Okay, yeah, I understand that. JVO, you're not with me tonight. What's happening? Internet bad?
No.
You want to do the explanation to Cassie for me?
I don't think I do a good job because
You don't.
to look for my calculator, so I don't know.
Oh, you stepped away. All right, fair enough. All right, let's go. So in order to calculate the variance of x, what we need to do is to find our expectation, which is going to be what they have there as x of p of x. And also we need to find e of the summation of x squared. So we're finding the summation of x squared, which is what they asked us right there. So what it is that we're doing, look at the formulation I gave you, Kasana. What we're doing there now, we need to sum it. We need to find the sum. So when we find the sum, we're adding the 0.8 to the 6.4 to the 10.8 to the 6.4 again. And then we're going to end up at 24.4. Don't do like a teacher and write 24.6, 24.4. And then I'm going to also sum the 0.4 to the 1.6 to the 1.8 to the 0.8, and I'm going to get 4.6, 2, 3, 4.6. And then it's going to be 24.4 minus 4.6 squares. See that now, hon? 2 marks for the value of Q. Okay, talk to me. How many marks for the variance of x, please? Another 5 marks. Okay. Kesano, can you habla me, please?
Yes, sir. I'm gonna get it now, sir.
But sweetheart, if you don't get it, talk to me now. What have you not gotten?
I still haven't gotten the answer for VAR. Or how you get it. Still don't understand how you get it.
All right. Do you have the last set of notes that I sent off to you?
Yes, sir.
Do you have the last set of notes that I sent off to you?
So if you send it, sir, yes, sir.
Okay, all right. So let me ask a follow-up question. Have you opened it?
So the last set of notes that I saw was post 8 and I opened it.
Okay, let me ask another follow-up question. Did you get a chance to read through it?
Yes, sir.
Okay. What were some of the things that you saw in it?
So I can't remember clearly.
All right. So what I went ahead and did something on probability.
Yes, sir.
Huh?
I saw a set of diagram, the correlation coefficient, and
No, 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 no. Unless I never sent it. I'm almost sure I sent you the probability distribution.
No, sir.
I didn't send the probability distribution?
No, sir.
Oh, Lord have mercy. When was class? Oh, class was Friday. Oh, guess what? Yeah, forgive me. RKC, never mind. After class Saturday, I couldn't even wait until 12 o'clock Saturday. After class Saturday, I was just out of it. Out of it. Totally. Okay, Kes, never mind. Let me see if I can. Yeah, how do I do this now? All right, hold on. All right. I will show you, hon. I'm using my cell phone and my computer is behaving foolish. All right. So, let me start from there. Have you calculated the mean? What's the mean? What's the mean?
4.6.
Okay. And everybody got the mean to be 4.6?
Yes,
Yes,
sir.
sir.
Yes, sir.
Anybody got something different? Talk to me now.
Sir, how do I add up XPX?
How do you calculate the mean? Normally, how you calculate mean?
So you add the number of terms and you divide it by the amount of terms that are due.
Mm-hmm. And you are correct. So you want to change? You want to change your answer now, then, Tamina?
Sir, but isn't this different?
Hmm.
Sir, isn't this different than the regular
All right. Let me interpret what is happening. Let me interpret what is happening. How many? Sorry, guys. I'm talking to you, but could call you, but I can't answer him just now. How many experiments do I have right here? How many outcomes?
4.
Very good. I have 4 experiments. I have 4 outcomes. All right, very good. How many times did I get 0.2?
Once.
How many times did I get 0.2? How many times did the probability 0.2 occur?
2 times.
How many times did 0.4 occur?
4 times.
0.3,
6.
0.1.
8
8.
times.
Okay. Anybody see where I'm going yet? Hmm? Somebody talk to me now, please.
Sir, what are you saying?
I'm saying to you, all right, so the random variable x, the probability of my 2 showing. I'm just trying to bring up my, and this thing is just not working for me tonight. Right about the minute in the mode to even. Oh no, but anyway. Oh, sorry. Forgive me. Oh, come on. Cassie, I'm trying to bring up with something so I can explain something to you. As soon as it comes up, I'll come back to this one. I'll come back to this one. I just want something to come up so I can project it. And it is kind of searching. Do me a favor. Are there any other parts of this question? Tantan?
Yes, sir.
Are there any other parts of this question?
No, sir. Just the 3 questions. Determine the value of Q, complete the table, and calculate the mean.
Mm-hmm.
Sir, I'll look if I can find the solution.
No, man, no, that's not that, you know. I'm just trying to project my I'm just trying to project my notes that that is up so that Kesana can see something because I didn't send off the notes with the stuff. So I'm at fault right there. Do me a favor. Find for me the other part of the question that speaks about the graph and the box and whisker plot. All right, there you go. Nice. No, go up to this the pie chart. All right. All right. Look at that for me, please, guys. Just read through that for me, please. I want everybody to participate, please. Please, everybody, I want all of you to participate. I don't want to sit down and just wait for an answer. Anybody have any idea what to do?
Yes, sir.
Kind of,
Okay.
sir.
Okay. All right. I just don't want you to sit down there and not do anything.
Sir, we finished.
You finish?
Yeah.
Finish, sir.
All right. What percent is A?
I didn't say percentage, it says how much.
Me know. I know. I'm asking what. Okay. All right. Let me not ask you like that. I am doing a question with you,
Say
but
would 10%.
A. All right. All right. Let me do it another way. It says no. Let me answer the question first before I use it as a teacher moment. The letter da 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 da. Determine the number of people shop on a Thursday. Thursday is which day? Thursday is E. How many people? Ooh. How many people shop on a Thursday?
20.
20, sir.
So that would be 10%.
Very good. Very good. Excellent. Everybody got the 20? Everybody got the 20?
Yes, sir.
All right. Who didn't get it? Speak up. Let us have a conversation.
Me, sir. I don't know
All
what.
right. You don't know what to do. Okay. No problem.
Yes.
Um. Anybody want to explain how they got it before I do my explanation? Or I want me to go my explanation first, and then you tell me how you did it.
Yes, sir. Please explain.
All right. So what I did, a survey was carried out using 200 people to determine on which day from Sunday to Thursday they shop at a new supermarket. The pie chart below summarizes the results of the survey, and it gave you the key A through E, Sunday through Thursday. The letters represent the number of people who shop each day. If E is equal to 2 times A and B is equal to 3 times A, determine the number of persons who shop on a Thursday. Now, what I did, and if you have a different explanation, go ahead and do it. But what I did was to say D is 65%, C is 5%. So between C and D, I have 70%. Can you agree with me or disagree?
Agree.
All right. So A, B, and E accounts for how much percent?
30.
30%. Very good. And how many parts up top between A, B, and E? How many parts in total am I sharing?
3.
No.
3.
What's it, A, B, and E?
Yeah, for A, B, and E, how many parts in total am I sharing for A, B, and for A, B, and E? How many parts in total am I sharing? How many parts in total?
30%.
No, I don't want it as a percent. Yeah, we know it's 30%, but how many parts in total? Look at the question.
Oh, 5.
No, ma'am.
3 out of 5.
No, ma'am. How many parts are we sharing?
60.
Huh?
Sir, I don't know.
Okay. All right. How many? I heard somebody said something. I just want to confirm. How many?
60. 6.
You said 6. 6 is a 0?
Yes.
No. One other person come. Momo. Momo not here? Yes, Manisha, talk to me now, man.
2, sir.
2? Who said 2 a while ago? If I say hey, Hambi, and he, how you gonna say 2? Like, seriously. Think about it.
Yeah, but we said 3. I said that wrong. So I have to say something else.
Yeah, but if me say 3 and that wrong, you can't say 2 because that would be wronger. Talk truth. That should be wronger. All right. So E, all right. So clearly this medication is running in, kicking in low. E is 2 times A. So how many portions is E shared in?
2.
How many portion is A shared in?
1.
How many
1.
portion is B shared in?
3.
How many portions in total are we talking about?
6.
Thank you, please. Thank you, please. Javia, if you ever open your mouth and say, sir, that me said, that's why I asked if it was 6-0. I say yes. Okay.
Because that's a total number of persons.
Okay. I love your honesty. Some other students will say, sir, that's what I mean. All right. So if you look at it, you see that it is sharing 6 parts because the question said to you, and I had to take a look at the question because I was like, what the heck? I mean, I took a double take and said, oh, this is what they're talking about. So A is, you notice that they had to compare the share, and the share that they're comparing, A is just 1. 1 portion. But it says that E is going to be equal to 2 times A. And B is 3 times A. So B is 3 times as large as A. So between B and A, I have 4 parts. Between, so therefore, I have 2 parts of E, 1 part of A, that's 3 parts, and 3 parts of B. So I have 6 parts there. Now, if I have 6 parts, and the total unknown portion percentage that I have is supposed to be 30, that means each part represents how much percent?
5.
5%. So because I know A is 1 portion, that means A is going to represent 5%. And B is going to represent 5 times 3, which is 15%.
Sorry, say that again.
And I'm saying to you, I'm saying to you, if you look at the question, it says to you that E is 2 times A. Do you agree with that?
Yes, sir.
Mm-hmm. B B is 3 times A. Do you agree with that?
Yes, sir.
All right. And they didn't give you any information about A, so it means that A stands alone. A is just equals to A. All right. So now A is equals to A. E is 2 times A, and B is 3 times A. So it suggests that E, between E and A, you have 3 parts. Talk truth.
Yes, sir.
You see that, Anil?
Yes, sir.
Right. And B alone is 3 parts. It's 3 times A. So what it is suggesting to me is that E has 2 portions, A has 1 portion, and B has 3 portions. Can everybody see that? Based on the calculation, you know. Can you see that?
Yes, sir.
Yes, sir.
All right, good. Now, among those 3 portions that were not represented as a percentage. I know I have a 65 for D and a 5 for C. So when I add that 65 to the 5, I'm going to get 70. So it means that my E, B, and A should all amount to 30% of the pie, because the pie, you remember the pie can be represented as degree or in percentage, you know. All right. So in this case, I'm going to have 30% left, because the sum of percentage is supposed to be equal to 100. Now, if I already have 70, 65 plus 5, 70, it means that I'm short 30%. So E, A, and B. 6 is a complete revolution. E, A, and B has 30 percentage points in total. Now, if we went ahead and did our calculation and recognized that we have 6 different portions, 2 for A, 3 for B, that's 5 portions, and A stands alone 6 portions. So if I divide my 30% into 6, each portion is representing 5%. So already A, I get 5 because there's only one portion in my. B, I get 10 because B have 2 of A. And C, I will get, E going get 2 of A. And B now going get 3 of A. So B going to be 15 degrees. A is going to be 5 degrees. 5%, sorry, 15%, 5%. Osh. Osh, the medication 16. Osh. And then E is E is going to be 10%. Are you see what I'm talking about, guys?
Yes, sir.
So say basically just add 5, substitute A in the equation, wherever you have 2A and 3A as 5.
No. All right, let me put it this way. If I have $100 to be shared among 3 people in the ratio of 1, 2, and 3. 1, 2, and 3. How many portions am I referring to? I'm sharing $100 in the ratio 1 to 2 to 3. How many portions am I talking about?
6.
6 portions, very good. So in order for me to find out which portion each person is going to receive, I have to now divide 100 by 6. I have to divide 100 by 6. And when I divide 100 by 6, what do I get?
Get the 1.
I get 16.67, don't it?
Yes, sir, and that would be the 1. And for the 2.
Yeah. I'm not relating it to the question here now. I'm just creating a different example. But yeah, you're correct though. So 16.6 would be that. And then now, if the person who's supposed to be getting 2 times will end up getting $33.33. And the person who's supposed to get 3 portions, person who's supposed to be getting 3 portions, supposed to end up with 50. So when I add 50 to 33.33 to 16.67, I'm supposed to give them $100. Talk truth.
Yes, sir.
So I'm saying to you, let us look at how many portions we have that are not assigned. E has 2 portions. Sir, how you know that? Because I say E is 2 times A. A in itself is 1 portion. Talk truth.
Yes, sir.
And B is 3 times A. So they tell you that E is 2 times A. That means you have 2 portions already. And A is 1 portion in itself. That means you have 3 portions. And B is 3 times A. So you have 3 plus 1 plus 2. So you have 6 portions that we're talking about. And 6 portions with a total of 30%. So when I divide my 30% by 6, I'm going to get 5% apiece. Then no, I know that, as I think Javier was the one who was saying that the 60.66 will be representing my A. That 5 is representing my A. In order for me to get my E and B, I have to substitute it into the original equation that they gave me as B equals 3A and E equals 2A. Also, yeah. Follow me? Hello? Hello?
Yes, sir.
Yes, sir.
Are you following me?
Yes, sir.
Please make sure you know. Oh, Lord.
Sir,
Uh-huh.
what about the approach where you know that the unknown is 30%, right?
Right.
And you find, I'm just smiling. Oh, you're so sick, and you're here.
Yep.
So the 30%, right,
Mm-hmm.
of the total number of persons, right?
Mm-hmm.
So it will be 30 over 100 times the 200, and you know that it will be shared for E, A, and B.
Right.
Right. So we have different approaches.
Which is what I said earlier. So
Mhm.
I am so what you have done just now is to speak of another approach. So what I'm doing, I am showing you my approach here, and then now I was going to entertain the other approaches. But you see, thank you, Miss, and you are on point, and that would have been the other approach that I am
Seeking,
that I would
right?
have taken, yeah. But I want them to see
Right.
what is happening. You notice it's not drawn to scale, because the other thing, Miss, I was going to say to them is, we just calculated A to be 5%.
Mhm.
But look at C, that is 5%. One man would have said, but sir, A and C are the same 5%, and they don't look like. It's not drawn to scale. Yeah, it's not drawn to scale.
Sir, I didn't do it like you want, Miss Henningham.
You never did that, Miss Henningham?
No.
Okay, great. So we can come to that. So Miss Henningham, do that part. All right. So let me just finish off this, and then I'll talk about Mrs. Henningham one, and then I'll come to you. So what I did was to say the 65 plus the 5 is going to give me 70, and I know I'm going to have 30 that is left. But when I look at it, it says E is 2 times A, and B is 3 times A. So A is 1 portion, because A is the base. A is what it is that they're using to compare. So it means that A is the base. All right? So since A is the base of the comparison, what we're going to be doing now is to look at my E to 2 parts. A is 1 part, and my B is 3 parts. So when I add all 3 parts together, I'm going to get 6. Now, I know I have 30%. So when I say 30% divided by 6, I'm going to get 5. So it means then that each part is going to be 5. So I'm going to go back and substitute. If E is 2 times A, it means that E is 10%. And A is going to be 5%. And the boy B better be 15%, because 15 plus 5 is 20 plus 10 is 30. So I now have my complete revolution amounting to 100%. All right? And then it don't end there now, because the question says to tell how much who shop on Thursday. Thursday is E. What? The letter represent, determine the number of persons. All right. So the E is going to represent 10%. I mean, if I find 10% of 200, you're going to get 20. So 20 20 people shopped on that particular day. All right. So let us look at how Mrs. Henningham did her stuff, though. What Mrs. Henningham said is that, you know, it's 30% of 30% that is left. So what she did was to say 30% is 30 over 100. 30 over 100. That's how you did it, Miss? Miss Metaway, Miss Henningham?
Yes, sir. That's how I did it.
Right.
Yes. The 30% of the 200.
So it's a 30% of the 200. All right. But
and then I allocate it as per the number of the unknowns, the 6 units.
all right.
Miss, can you repeat what you did, please?
Okay. So what I did, I take the known and then move to the unknown. So I have 65% and I have the 5% which will give me the 70%. And I sum them together. So knowing that percentage is out of 100, finding the difference, it means that 30% represents E, A, and B, right? So 30% of the 200 represents E, A, and B. Using the information they have given to say that E is equal to 2A and B is equal to 3A, the common variable there is A. So I can form an equation to equate to the 30% of the 200. And then I solve from there. What is A? And then I know that the result I get, E will be 2A.
Okay, thank you, Miss.
You're welcome.
All right. Anybody else? Somebody said they got something different.
No, Miss, I was saying I did. No, sir, I was saying I did the same thing as Miss Henningham.
Oh, okay.
Sir, I was the one who said I didn't do it that way.
Okay, go ahead and tell us how you did it.
All I did was find 70% of 200, which was 140, and then I just subtract the difference, which would be 60, and then I said 60 divided by 6, and I get the 10 as A, and then it's just the 2 times A.
Yeah. To be honest with you, while Mrs. Henningham was explaining her stuff, that's exactly how I did mine. I did it the second time, Nikki. So while Miss was talking a while ago, I look at the question and did it another way, and the other way that I did it is exactly how you did it.
Great minds, sir. Great minds.
Great minds. Because let me just say what Nikki said a while ago is that she found 30% of the number of the 200 and she got 60, but she now knows that she has 6 parts to talk about. So her explanation came up about number of parts also, and then when she divided that 60 by the 6 parts, she get 10. But she know that and 10 will represent the single unit, which is A, and then she said 2 times 10 is equals to 20. So she got a 20. All right, fair enough. I think we have spent enough time just looking at the question, in different ways.
Sir,
yes, honey.
come back in. Oh, you answer the question, sir.
What answer which question?
This number 4. What is the answer?
Hold on, no, you lost me. Where's number 4? Oh, number 4 is going to be 20.
So how you get it? You can repeat, please? It just come back.
All right. So what I was saying is that it says E is 2 times A, is 2 of A, and B is 3 of A. So A is a single portion. E is 2 times what A is, So it's going to be 3 portions in total, and B is 3 times what A is. So those all 3 units, 2 plus 1 plus 3 is equal to 6. So I have 6 parts to be shared among E, A, and B. But I also recognize that I'm going to have 30% to share. So 30% to be shared in 6 equal parts. It means that each part will get 5%. Sir, how you know that? Because 6 times 5 is 30. So 30 divided by 6, I'm going to get 5. So it's 30% divided by 6, I'm going to get 5%. So each portion is going to represent 5%. And then if E is equal to 2 times A, and I know A is representing that single portion, which is 5%, it's going to be 2 times 5, which is 10%. And I want to double check I know I'm right. 10% for E, 5% for A, that's 15%. And I'm saying that B is 15%, and 15 and 15 is 30. All right? And I know it's 30% that I have left. And then now, if I find 10% of the 200, it gives me 20. 10% of the 200 will give me 20. So therefore, I'll have 20 persons represented, well, shopped on Thursday. Get it, Nikki? Get it, Cassie?
How much number of person they said, sir?
20. You got the 20? No, so I get the 20, Cassie?
Yes, sir.
You see I get it now?
Mm-hmm.
No, I know better than that, Cassie, because I know you don't see it. From my here, we answer it, I know exactly what it is. Come, look at it.
Okay.
Yes, I'm hearing you. You see no case?
Yes, sir. Yes, sir. See, oh, you get the 20. See,
All right then. Okay. All right. Hold on half a second. Yeah. Tan, scroll up to the other question in the meantime for me, please.
All right, thank you, Tantan. All right, guys, come on. We need to make sure. So, guess what? Now we're timing all of what it is that we've done so far with the explanation as to these and all. All right, let me give you estimate the median weight before and after the diet. Oh my gosh. All right, let me just read the question. It says 20 overweight children. My God, they're mean. 20 overweight children.
Sir, it coming like this year the rating obesity spike because this is the second time they're talking about exercise and overweight.
Can I tell you? They're awful. 20 overweight. Why do you have to say overweight? I know, 20.
Sir, obese is nastier word.
Obese is a nastier word?
Because if me did read that, me that take offense. And that me say.
Okay, to each his own then. So 20, better than just 20 fat children. All right, but anyhow.
No, sir, you can't call the penny name fat.
Okay, I guess the milder word then is overweight. So let us stick with overweight. 20 overweight children of ages 4 and 5. Oh my God, 4 and 5 were enrolled in a diet program for 5 weeks. Oh my goodness, that is not good. At those ages, I'm supposed to be eating all the sweetie and chocolate that I can eat, because when I get to my age, I can't do that. Anyhow, the box and whisker plot summarizes the children's weight in kilograms after 5 weeks of the diet on the diet. And it gives before the diet, oh my God. And after the diet, them shrink. Estimate the median weight before and after the diet. Okay, when they estimate the median weight before is what?
35.
Some say 2. And what's Q2 after?
30.
Everybody say that?
Yes.
Yes, sir.
Yeah, man. Me agree with that. How much mark for that? 2 marks? Oh my gosh. All right. So I agree with you. Everybody see this? Is there anyone in the class that is not seeing how we got the 35 and the 30?
Yes. No, sir.
I mean, no meaning what?
No,
You don't see what
meaning
you don't see what
how
get
you
it?
get it. And no further explanation.
All right. What she say? Is it that you don't see how we get the 35? That's what you're saying, right?
No, sir. Said I see how you get it. I just said no, as in I can move on.
Oh, okay. Got you. Very nice. Come on, scroll up for me, please, Tantan. Thanks. Stay close to it, Tan, because we may need to. Oh, Rockstone. Hey. You know, so the man might ask if you don't know what conclusion can be drawn. What conclusion can be drawn about the special diet program? Give a reason for your answer. So what conclusion can be drawn about the diet program? All right, go back up to the background whisker for me, please.
Work got them lose weight.
Wait, say?
Work got them lose weight.
Oh my
so
God.
So them start eat fruits and vegetables.
I don't think so that today.
So them I lose 5 kilograms.
Yes, it's effective.
A week, I guess.
Yeah, the diet at work.
Yeah, them I lose 5 kilograms.
Scroll up. Let me see the question again, Tantan.
Sir, I'm on the question.
No. I can't see that. I can't see part 2. I just want to see a little bit of part 2 so I can scroll between the graph and part 2. Anybody can see part 2? All right. I can't see part 2 now, but all right, I can see it now. Thanks. What conclusion can be drawn about the special diet program? Okay. What conclusion can be drawn? So you're saying that the special diet program is working? That's all?
Yeah. So
Yes.
they lose 1 kg each week.
Well,
So should we talk about like the length of the whiskers or stuff like that?
and that's why them get box and biscuit part, because I interpret it. So know you're going where I'm going.
So we
So
can use back the word median, like it I said, like the median weight loss was 5 kg for the overall thing or something.
and that too, and now you're speaking like my math students, developing your analytical skills. Yeah, man. So what it is saying that is that Q2 after the weight loss is 30. So it means that how many students we're talking about? How many students? Them tell you how many students? Sorry, I'm just trying to see. How much? 20. All right, hold. All right, go back up, Tantan. So all right, let me give you some facts. Among the 20, clearly there was a reduction in weight loss. I can't say everybody lost the same amount of weight, from day to day or from week to week, but collectively they would have lost. If Q2 is a median and Q2 is 35, 35 times 20 would be 700. So collectively, they weighed 700 pounds. And not so much. Yeah, 700 divided by 20. That's what Jesus. 700.
Really?
Yeah, 35. Yeah. No, I want to sleep, man. I take the tablet and sleep or work with me. And right, so we have 70 pounds. And then now the 30 times 20 is going to be equal to, so together, collectively, among the 20 students, they've lost 100 pounds. 326. Yeah. So they have lost 100 pounds, right? So that's one analysis that I get from it.
Sir,
Uh-huh.
when you say you get the 700, what you do afterwards, sir?
I did the same thing like what I did to get the 700 to get the 600. So I found collectively the weight of all 20 students before, and I got 700 pounds. And then I did the same measurement after the exercise, or I exercised after the diet. And I got collectively them weighing 600 pounds. I can't tell you if A, B, C, D, right down to number 20, which one lost, because you may have one of them who have a stubborn fat and that one don't lose no weight, none at all. But we have somebody else who, by the time I say lose weight, they would have lost the weight. All right. So and then no, one other thing that I'm seeing here, when I look at my minimum point, before my minimum point was at 25. So it means that my minimum point now went to 20. But watch it now. Before the diet, I had somebody in the class weighing 60 pounds or 60 kg, whatever the unit is. Right? Very good, Casey. Right? And then after the diet, them gone to 50. So the maximum, since they're being mean, let me just continue being mean. The heaviest person in the class was 60 pounds. Or is it pounds or
Sir, the picnic can be 60 kg.
Kilogram.
Sir, that impossible. That's
it's
how that
kg.
did.
It's
Sir,
kg.
one child weighs 60 kg.
That's like 100.
Sir, that is how much like an adult suppose, like a adult, like a teenager, like a 5 foot something person supposed to weigh. Sir, one
And
That's
we
person.
but
have some kids in our like you ever hear them talk about
132.
big six? They have some kids that
well
talk
to be
you know.
to be honest with you, at 60 kg work out
Sir,
to be
that's a
134.
yeah, 32.
Yeah. So you understand why they put them overweight now? All right. So they are very overweight. So what you can say is that if you want, you can say Bigs, they weigh 60. Bigs lose some weight now, Bigs weigh 50. All right. So 50, I am not feeling well. I should behave myself, right? But the maximum weight of the class, the heaviest person in the class was weighing 134 pounds, 0.4 pounds. And then after the exercise, they weighed 112. So guess what? Exercise at work. Exercise is working. Now, let me just point out something. You notice when I was doing the analysis for the box and whisker, I had put a diagram with two of them together because it makes much an easy and clearer sense when it is that you have them together, so it is that you can see the readings. But yeah, so come, let's go back to the question. I just wanted to see if you can analyze what is happening. Interestingly, 25 minus 40 is how much? 50? And what is 30 minus 45? 15. Okay. So interestingly, the interquartile range remains the same. There's no great difference right there. So yes. So what conclusion can be drawn about the special diet program? Yes. The special diet program made sense because the lightest person in the class before the diet program was weighing 25 kilograms, and now the person weighed 20. The heaviest man was 60 kg, now weighed 50. The average range of students in the class moved from 35 to 30, right? And I think that's the reason they wanted to use, because they asked you in part A, estimate the median weight before and after the diet. So I think that's a reason that they want, because you'd have calculated Q2 and Q3. So the mere fact that you got Q2 to be 30 for the after the diet is suggesting that the weights collectively would have decreased. So more students, yeah. So students collectively lost some weight, which is why Q2 value changed, right? So because they asked when part 1 connects to part 2. But if you didn't write that as a stuff, but you wrote, look at the whiskers, you can't use the length of the box, because the length of the box for both of them are the same. But the mere fact that you can analyze the box and whisker by speaking about the minimum value or the maximum value, I quite frankly believe that CXC would have given a mark. I think what the answer that what they're looking for is just to talk about the Q2 values, because that's what they asked in part A. But if you went up, because I want only one conclusion, only one. But because if you went outside the box now and speak about the maximum whisker or the minimum whiskers, and you compare both, they will give you the mark also. Right? So that's very good analysis. Any question?
So if you have a put
Yes?
no worries, sir. Be a nice number background, sir.
Okay. All right. Is there another part of this question, Tantan?
Sir, can you go over about the answer?
For what?
The second one.
So I'm saying to you, Q2 is 30. Both of them are Q2, Mr. Shandy. Q2 after diet is 30. Q2 before diet is 35. So it means then, remember Q2 is talking about the average, Q2 is talking about the average, all right? So, and remember how we calculate average. I'm coming back to that one for the first question, the question we did before this. How we calculate average is, add up all the weights of these 20 students. I'm going to add up all the weights of the 20 of them. I divide by 20. I'll divide by 20, the number of students I'm talking about, right? So really and truly, I am summing, and I'm using that word particularly because I want to use it to explain what it is I'm going to go back to. I am summing, so I'm finding the summation of X, which is like the expected value of X. I'm summing all the values of X, dividing by the number of outcomes. So there were 20 outcomes, because we're talking about 20 children. All right. Now, What I'm saying to you is collectively, because the average was 35 compared to the average after being 30, it means that you had bigger numbers in the first one compared to the second one, because you had bigger numbers, so you get a bigger average. Smaller numbers, you get a smaller average. All right? So it suggests that, yes, the diet did work for true, you know, because the average range of the class, when I calculated it, when I multiplied the 35 by the 20, I get 700. And when I multiply the 30 by the 20, I get 600. So on average, the students in the class collectively lost 100 pounds. Say so many different explanations I give you, any one of them, something CXC will do it. But I think though, the main one they want is a Q2, the comparison of the Q2 values. Make sense? Agreed?
Yes, sir.
Make sure you know. All right. Thanks,
So
Dan.
it's just 2 marks, so.
Yeah. All right. So this was a 4-marker question then.
Yes, sir.
All right. All right. Are you seeing any other in this one? No, that's not it. Oh, that's the one we just did. All right. All right. Hold on. No, sorry. Go back. Let me see that. Let me see that. Let me see that graph. No, let me see the graph. The graph on it. Scroll down. Let me see the instructions. Okay. Okay. Scroll down for me, hon. 10 to 19 is 10 to 19 is 5. Scroll again. 10 to 19 is 5. Scroll again. All right. Stop right there. No, I'm not seeing the graph. All right. All right. Cool. Mm-hmm. All right. 4 marks. Wow, they love to give marks. All right. Let me go back up to the table, please. Part A.
Sorry, you see it?
I'm seeing it. Yeah, yeah, yeah. All right. Scroll up for me, please. We're coming back to this question. It is solvable. I've covered this with you. Scroll down. Let me see something else. Oh, that's the end of the paper.
Sir, well, not the end. I'm going backwards.
Oh. All right. All right. Let me go back to the question that we're talking about. Let's go back to the question. The one that we did with the var x, the variance. And I'm going to go back to the question. How many experiments did I conduct?
4.
4.
No.
20.
20. I conducted 20 experiments. Sir, how do you know it? Let us read it. Remember how you were able to calculate, and this is the other explanation I'm going to be using when I was looking back at the question. You know, that's what I tried to do, is to find multiple ways of explaining to you what is happening. right? Multiple ways. Where was that, Lord? I should have taken those tablets. Yeah. So what I'm saying to you is, if the sum of the probabilities is equals to 1, if the sum of the probabilities is equals to 1, that's how we were able to evaluate Q to be 0.3, because we added up the 0.2, the 0.4, and the 0.1, and got 0.7. And we know that the sum of the probabilities cannot exceed 1, so it must be equals to 1. All right? So that's how we got Q3 to be equals to.
Sir,
Go ahead.
sir, we just divide 1.8 by 6. Did I get them all?
You just divide what?
The one for x be x by x. We get px.
Forget what?
Sir, if we get q.
Oh, so you divide
0.8 we get q. The 1.8 by 6 we get q. That means
yeah, you said I think get the 0.3, but that's not really the methodology. The methodology, what if they never give it a 1.8 right there? So could you have gotten the 1.8 otherwise? Yeah, man. The sum of the probabilities is equal to 1. The sum of all probabilities is equal to 1. So what should happen? You add up the 0.4, 0.2, 0.4, 0.2, 0.1 to give you 0.7. And when you subtract 0.7 from 1, it's supposed to get 0.3. Right?
the marks, eh?
I don't know how they're gonna manage it now. Maybe.
So all you said them get the 10.8?
What? They gave you the 10.8. But you can calculate to find out if the 10.8.
I know, sir, but for me, if you know how to get the 1 for the 2, 4, and 8, I have to know how them get the 10.8 underneath the 6, I'm never know how them do it.
But Kes, respectfully do you know? We cannot finish this question, you know. I don't know if you were in here. We finish the question, you know. I'm only going
Sir,
back.
remember said it's supposed to explain it to me, but my phone got dead, so I move on afterwards.
Oh, okay. All right then. All right, no problem. Right. So what it is that we're doing, the methodology that I want you to understand is that the sum of the probabilities equals to 1. The sum of the probabilities, the sum of all probabilities can pass 1. The sum of all probabilities is going to be equals to 1. So you add a 0.4, you add a 0.2, you add a 0.1. And what is left? Better be Q. Because the sum of the probabilities must be equal to 1. So that's why you got Q to be equal to 0.3. That's why you got Q to be equal to 0.3. That's why you got Q to be equal to 0.3. All right? And then now, getting the 0.3 for Q, what we're going to do now is multiply the x by the 0.3. And that's how I got the 1.8. So we're going to multiply 6 by 0.3. And that's how they get the 1.8. So what you would have done is work the question backwards. Because they could have given the question and just asked to find Q. You notice when I'm giving you the question, I don't give you Q in there. I mean, I don't give you the 1.8. I only give you the unknown and ask you to work it out. And you better work it out. Get me?
So you only give us the first 2 rows.
Say it again?
You only give us the first 2 rows.
I only give you the first 2 rows. And it's not 2 complete rows neither. I'll give you 1 complete row, and then I give you an unknown, or sometimes I may give you 2 unknowns in there.
So it's 4, sir.
Right. Very good. All right. I had said I was going to do something. Cassie, all right, no, hon?
Yes, sir.
Cass, stop. Huh?
Yes, sir.
Is that Is that yes or true, yes, or is it a false yes?
Sir, I can't tell you that, sir.
You can what? All right, let's go.
Sir, question.
Mm-hmm.
Sir, would the P represent the 0.2, 0.4, Q 0.1, and then the small x represents 2, 4, 6, and 8?
Mm-hmm.
Okay.
Mm-hmm.
Kisane, you could look at it that way.
But don't look at it as if
Repeat, Tanya.
no. Hold on. Don't look at it as if you're multiplying. Don't tell her that because I don't want Kesana to go think say the x inside of the p is what we're multiplying inside here. So
Oh, yeah.
is what I'm saying.
Yes, sir.
All right. Let's see. All right. Look at what is happening. Look at what is happening. If I allow x to represent the number of students in my class, and I'm saying there are 2 students who receive a probability of 0.2 in being able to run. There are 4 students who will have a probability of 0.4 able to start a race and complete the race. I have 6 students with a probability of 0.3 who, when them say on the mark, set go, as them say go, them drop. I have 8 students who shy out of the race because them say them can't run, period. What I'm trying to say to you is that in total, it's not 4. I have 4 columns because my data is grouped. So I have 8 and 6. That's 14 plus 4, 18 plus 2, 20. So I'll have 20 students. Or you never tell me who it was. So I'm gonna have 20. So when I sum my XPX, my XPX is gonna give me my sum. And that's what I get as 4.6. As I get at 4.6. So I'm going to divide that 4.6 now by 20. And I'm going to get 0.23. And that will be the mean of the data. And I think that answered the question that way. I think that answered the question that way because a lot of students may think that it's only 4 things that they have. It's only 4 sets of data instead of 20. Are you with me here? Do you understand and see how I get the 20 and not 4?
No, sir.
So, sorry, say that again. He said no?
Yes, sir. I said yes. I understand.
Oh, you understand. And also, so Tani said something earlier that I want to correct. Tani said, sir, but we calculated the mean already because the summation of x will give you the mean. No, the summation of x is going to give you a portion of the mean, which is the total sum. You now need to divide by the number of outcomes or items or whatever it is. So that's why you now need to divide the 4.6 by 20 in order to get what it is that you're getting there.
Sure, that's 0.3. 0.23.
0.23, yeah, 0.23.
Sir,
All
but
right.
then var x is going to be a big number.
Var x is what? Var x is in the value of var x don't change, you know.
Oh.
Remember, var x is not dependent upon the mean, you know. Var x is not dependent upon the mean. You calculate var x by saying the sum of the x squared term minus the sum of the x terms squared. So var x is not going to be dependent from that. All right. All right. So I've gone through 2 of those questions from the areas that we've already completed. Can you look at it and, you know, what time is it? Oh, I got 4.6. We add up all, we sum everything in that third column, third row. The xp of x, we summed up all of those. We got 0.4, 1.6, 1.8, and the 0.8, and then we get the 4.6.
Sir, so var x would be 24.3471.
What?
Sir, remember if we divide the 4.6 by 20, you're going to get 0.23, and then when you square root, define the square 0.23, you're going to get 0.0529, and then when you add everything in the fourth column, in the fourth row, and you subtract that from 0.0529, you get 24.3471. So that's why I said the number going to be large.
I disagree with you.
Okay, so what did I do wrong?
All right. So what I'm saying to you is that the mean is not dependent upon the variance. Okay. All right.
Sir, what are you saying? That the answer is wrong?
Oh, all right. I'm trying to. Hold on. Let me see if I can straight from here. What's your 8:30? Let me not show you something quickly, please. I did not release you. I see any question in the meantime, Penny? Any other question in the meantime? So at least you can just put it on the screen and members just screenshot it for class for the next question. Work as past paper. Just go through quickly for me, please, and see if see any other. In about 2 minutes. I'm trying to bring up my document. I bet you a little bit. I bet you any money that I sent to her. Okay. Find any other, can you? Find something else?
Sir, not yet.
Is that a stem and leaf?
Yes, sir, this one.
All right, let us see. This thing that coming up here. I'll send it off in the group afterwards. Let us just do this one mark and we'll call it an evening. It says the following stem and leaf diagram summarizes the length of time in minutes spent by 13 employees in completing their job. So 13 employees, that means the middle number is how much?
Seven.
Huh?
7.
All right. So count 7 for me from 5.
11.
What's the median number?
11.
Very good. Everybody say she got 11?
Yes, sir.
And it's not just 11, you can say 11 minutes.
11 minutes.
All right. We'll continue with the past papers on Friday, God's willing. And I'm going to see if I can intersperse it. By then, I know I'm supposed to be feeling coming back to a 100. I'm very nasal, as you can hear. I'm not coughing as much. I'm still coughing, but not coughing as much. I'm very, 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 very nasal. Most of my breathing is through my mouth. So I didn't expect to be talking so much, but I wanted you to do working, but guess what? I'm happy. The pair of us are seeing improvements and, stuff in your performances. So on Friday, all being well, I'll do 1 or 2 a little bit more, but we still need to just use the thing and work for the stuff and on the questions. I want you to start working the past papers here. I'm particularly concerned about the ones that I have completed earlier on, like when I forget it. And remember to say, drink for Jesus. Miss, you want to close out? You have anything to say?
The ball is in your court, students, and guess what? You know what you have been working for, so claim it, and you have some time to put in that extra work to move from the level you think that you're at to what you can really achieve. Right?
Very
The
nice.
sky is the limit. Yes. And if we are believing in you, you can believe in yourself and achieve.
Thank you, Miss. Very well said. All right, guys. Say a gentle Jesus. And all the best. We'll
Sir,
continue.
quick question. How she got the 11?
All right. So we know that it's 13. We know that it's 13 employees. So a half of 13 is going to be, sorry, the middle number. Sorry, you're going to do n plus 1 over 2. Let me use the terminologies. Remember when we have the data group and we're trying to find the median term, we add 1 to it and divide it by 2. I gave you this.
Yes, sir.
Right. So when we add 13 plus 1 is 14, 14 divided by 2 is 7. So the 7th number is going to be the median. So you can count from the 5, 5 is 1, 6 is 2, 7, 3. We're looking at the leaf now, you know. 5 is 1, 6 is 2, 7 is 3, 8 is 4, 9 is 5, 0 is 6, which is 10, 1 is 7, which is actually 11. And if I count 7, 9, 4, 6, 2, 1, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right? So if I count from top, you'll recognize that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right. So you have 13 pieces on the leaf. And if you come to 7, 1, 2, 3, 4, 5, 6, 7, from the bottom up, number 7 stop at 1. And if you count from the top down, number 7 also stop at 1. So 1 is going to be the median value. And that's just a kind of 1 marker.
Oh, so the stem is 1 and the leaf is 1 as well.
Right.
Oh, okay.
So you see what I put over here, so? 1-7 means 17.
Okay, so I get it.
All right. Bless the heart. Take care, guys.
Bye, sir.
Sir.
Oh, that was bye. Okay.
Bye, sir.
Bye-bye.